Alright, so I know I said I was only going to make one of these, but I'm going to make two. I'm going to make two different tank problems, because there are two concepts that need to be known, I think. The tank problem, very classic, they love using this thing. So I'm trying to help as much as I can. First thing to note is that when you've got a tank, you need to make that a little bit lower. You've got a tank. Okay. Where does similarity come in? Well, as water rises or falls, you're going to get this pyramidal structure that's similar to this entire thing. So that's where similarity comes in. As the water rises or lowers, the shape that the water takes is similar to where it was previously. So I hope that explanation helps. Now, for this problem, if you look at how everything moves, as you increase in height, you're going to increase in, I'll call this one width, and increase in length at the same time, meaning that height is proportional to length, and height is proportional to width. So we'll say C1 and equals C2. Volume equals, I'm gonna omit the constants right now, because it's kind of dependent on the prism, and it's all gonna get canceled out later anyway. So as you saw before, HLW, volume equals, how do I want to do this? I'll solve for L for this one. So I'm going to put it in terms of H. L is going to be, let me put the H down first. Then L is going to be H times some other constant. I'll call it C3, doesn't really matter. Times over here, solve for W, H times C4. When you put all these over another one, H1 times H1 C3 times H1 C4, these cancel, and you get V over V1 equals H cubed over H1 cubed. So that is the equation we will be working with. Now, I'm just showing you that this works. Hopefully, if you get a problem like this, you will not go and prove all this. There's no need. If you see that, if you observe that it moves like this, you can immediately know that it's cubed. If when one variable is changed, when one one-dimensional variable is changed, the other two also change, then you know it's cubed because of what I showed here. Now let's use that. Height of the tank is 15 feet. Wait, let me read the whole thing. An upside-down pyramidal tank of height 15 feet is filled to the top with water. If 1/9 of the water is drained out, then the height of the water is a cube root b feet, where a and b are integers and b has no perfect cube factors larger than 1. Find 2a minus 3b. So essentially what this is asking for is for us to just find, it wants us to find the height after 1/9 of the volume is drained out. So let's say it starts with, a height of v, and it goes, or let's say it starts with a height of v naught, and goes to v. We know that 1/9 of the water is drained out, meaning that when it goes from v naught to v, 1/9 of v naught is going away, so minus 1/9 v naught, which means that what you're left over with is 8/9 v naught. Oh god, g equals v. So that's, believe it or not, really all we need. We know that h1, just going to use, yeah, okay, h1 cubed over h2 cubed equals v1 over v2. Probably should use not and normal, but whatever. We know that that's true. We know that this 15 feet, I'm shaking this thing around a lot. This 15 feet corresponds to when it's filled to the top. Which means that we'll say that the bottom two are when it's filled to the top. So h cubed over 15 feet cubed equals v, or actually, when it's filled to the top, it has one total volume of v naught, and when 1/9 is drained out, you're left with 8/9 v naught. These cancel, and you're left with 8/9 up there. H cubed equals 8 over 9 over 9. I always do that for no reason, times 15 cubed. Now from here, what I am going to do is I'm going to separate 15 cubed into, actually I'm going to do it for 8 as well. 8 is 2 cubed, and 15 cubed equals 3 cubed times 5 cubed. All over, I'm going to put 9 in terms of 3 squared. Now, the rest is pretty simple. This cancels with this, leaving 1 3 over there. And when you take the, oh god, what the hell? Okay. When you take the cube root, the 2 and the 5 come out. H equals 2 times 5, 10. Actually, just to make that a little more obvious, the 2 and the 5 came out. And what's left is the cube root of 3. H equals 10 cube root of 3. Now what did it want? It wanted, the height of the water is 8 cube root 3. A cube root b, oh my god, a cube root b, which means that this is equal to a cube root b, showing that 10 equals a and 3 equals b. It wants 2a minus b. 2a, 20. Is it minus b or 3b? Yeah, it was minus 3b. I thought so. 3b is 9. That gets you 11. I hope that one wasn't too long. I think that this one is relatively simple if you get this. So I'm hoping that made sense. If you go look at 2 years ago, question 2, there's a problem just like this, but it is actually a cone. Hint, hint, it does not work any differently. It's the same thing as you increase in height. The radius increases in both length and width directions, meaning it's going to have the same h cubed. So try it out. Have fun. Hopefully that helped. Let me go, bam, back there, stop recording.